Electricity is the heartbeat of modern India. It lights our homes, powers our industries, runs our hospitals, and connects every corner of our nation. Yet behind every switch and circuit lies a silent responsibility, the responsibility of safety. Every year, thousands of electrical fires and accidents remind us that one loose connection can change lives forever. According to national data, over 25,000 electrical fires occur annually, claiming lives, destroying property, and halting progress. Most of them could have been prevented through better design, better supervision, and better awareness. The country witnessed repeated accidents and increase in casualties due to poor installations, lack of inspection, and absence of accountability. They decided to take action. Thus began a movement, the National Federation of Engineers for Electrical Safety, NFE. Started with a small group of like-minded professionals with only passion and purpose. They began spreading awareness through webinars, workshops, and training sessions, one city at a time. What started as a conversation soon became a nationwide movement for safety and change. In just a few years, NFE has grown into one of India's fastest-growing engineering societies, uniting over 2,500 plus engineers across 12 chapters in India. Each chapter drives its mission through learning, collaboration, and public awareness campaigns. NFE has conducted over 180 webinars and 50 workshops on the National Electrical Code of India, in collaboration with the Bureau of Indian Standards, BIS. These programs are helping thousands of engineers stay updated with safety codes, best practices, and new technologies. NFE's signature annual event, Elect Safe, brings together government leaders, consultants, manufacturers, and innovators. It celebrates best practices and showcases electrical safety products that make buildings and industries safer across India. NFE's student chapters inspire young engineers to design responsibly, while its professional programs help experts achieve certifications that matter. Together, we are building a new generation of engineers who think safety first. From a humble start to a national movement, NFE continues to lead with integrity, commitment, and purpose. Because electrical safety is not just a regulation, it's a responsibility. Together, let's build an electrically safe nation. National Federation of Engineers for Electrical Safety. Join NFE as a crusader for change, spreading awareness, training professionals, and advocating compliance.
Today we are honored with the presence of Dr. Jens Gowling. As soon as we met only last month in Delhi, where Dr. Jens introduced the IEC TS 63527. Then we requested him for a webinar in our platform, and he immediately agreed, and today it is happening. A small introduction which I wanted to tell you is we in several groups of ETD committees in BIS, we are working we are working on several standards, especially standards relating to products, standards relating to installation practices, and so on. For the first time, there is a standard probably for the maintenance or safe working of electrical installation. First of all, I congratulate Dr. Jens and the team who made this particular standard, safe management and operation of electrical installation, which explains the operational procedures, working procedures, and maintenance procedures in an electrical installation. Irrespective of the voltage, the standard is applicable to all the voltages, low voltage, extra low voltage, as well as high voltage. So without much time, I request Dr. Jens, welcome to our platform, and please start the presentation.
Yeah, thank you very much for the introduction, and a very warm welcome from Germany. Good afternoon, dear participants. Like Mr. Kawakuma said that last month I made this presentation in our symposium which was organized together with general meeting of IEC. And I think it is a good chance to present this with more details on this platform. Yeah. So
Yeah. You can share the screen.
Yeah. I hope it works.
Yes.
Yeah. Okay.
Yeah. Perfect. Perfect.
Yeah, so I want to start with my presentation. I was also the chairman of the PC 128, which elaborated this technical specification. I want to start with the question, how do we define operation of electrical installation? All the activities that include the work necessary to enable an electrical installation to function. These activities include actions such as operation, control, verification, inspection, and maintenance. And they include both electrical and non-electrical work which are made near the electrical installations. What are the principles of safe operational management and safe operation of electric installation? On the right-hand side, you can see these are the German standard for this matter. And this yellow one, this is a booklet with more explanation for the practical use of this standard. What are the principles? These are organization and standards, competency requirements, functions and responsibilities, authorization and appointment of persons, confirmation of the safe design and installation of electrical systems, work procedures, and safe maintenance. And now the most important question, why normalize the operation of electrical installation at IEC level? I will give you a little view to the history of these, the standardization of electrical operation. Many committees develop standards or participate in standardization related to the operation of electrical installation in their field. And this can lead to overlap, double standardization, uncoordinated requirements, and unsafe working conditions. And the aim of this project is to take a decisive step towards the gradual harmonization of safety levels during operation. Here I have some examples of IEC committees which are providing standards on the operation of electrical installation too. For example, IEC TC8, System Aspects of Power Systems. TC9, Electrical Equipment and Systems for Railways. TC31, Equipment for Explosive Atmospheres. TC64, Electrical Installations and Protection Against Electric Shock. TC78, Live Working. TC82, Photovoltaic Solar Power Systems. TC99, Insulation Coordination and Engineering of High Voltage Electrical Installations exceeding 1 kV AC and 1.5 kV DC. And so on. There are more IEC technical committees which are in the same, where we found some overlaps. Now, let us come to the history of the IEC PC 128. In some European countries that started around in the 19th, the beginning of the last century, first national electrical operation standards in Europe. And you know, in Europe, we have many countries and we wanted to have a common market. And now one key team from Portugal, from Spain, from Italy can work in other countries. And this is the need to find a common rule for electrical works. And so we started with the work in CENELEC, this is a European electrical organization, in 1992, with the installation of a BTTF 62.3 of CENELEC. BTTF, this is the task force of the technical board. And they could publicate in 1996 a first edition of a European standard. It's a common standard, which is valid in all European countries. And in the years 2018 and 2019, this BTTF proposes to submit a standard EN 5110 as a new work item proposal to the IEC, because we are living in a global world, and it is not only Europe. We are not alone and separated. We are also working together with other continents, and that's why we decided it's better to have a common basic for all these electrical works in the world. And the German National Committee proposes the creation of a new project committee on the operation of electrical installation. This was in November 2019. And in February 2020, the Standardization Manager Board of IEC reports the approval of installation of a new PC 128. And the French National Committee offers to serve as a secretariat. This was Serge Yesso, and he was assigned in May 2020, and myself was delegated as chair to this IEC PC. And this year, in July, we asked from our PC 128 that we could not finish all our work, and we see more things to normalize. And so we asked SNP if we can install a TC 128, TC, Technical Committee, which can publish also technical standards and not only specifications. And we received the answer that we can install it. And the next month, in August this year, we can find the new publication of this technical standard 63257 edition 1. It is now available. The work when we starting, I thought that we need 5, 6, 7 years, because it was difficult enough to find a common way. But finally, it was faster. We had the first plenary meeting. It was in October 2021 in Paris. Then we have a second plenary meeting. It was in 2022 in Offenbach, Germany. A third meeting, 2023 in Helsinki. The fourth meeting, 2024 in Santiago. And this year, the last meeting in February in Sao Paulo. So we need only 4.5 years to finish with our work. Now I want to introduce the scope of this IEC PC. It is applicable to the operation of and work activity on, with, or near electrical installation. And it is applicable to voltage levels from very low voltage to high voltage. And applicable to installation for generation, transmission, conversion, distribution, and finally also for the use of electric power. And what we define for electrical installations, these are permanent and fixed installation, such as distribution installation in a factory or office complex. Okay, will not continue. Sorry, my presentation stop.
It got struck. Probably then you can unshare and share it again.
Now. Okay. Temporary installation, such as those on construction sites and others, are mobile or capable of being moved either whilst energized or whilst not energized nor charged. And then we decided to install two working groups to divide a little bit the work. We had these two working groups, and this was working group 1 with the subject of terms and definitions. It was development and compilation of terms and new dictionary for the operation of electrical installation. And working group 2, technical specification, editing and supplementing the existing text of standard in EN 5110-1 in an IEC technical specification. This was the base what we used, the European standard. And working group 1 was the chair who came from Ireland, and for the working group 2, he came from Finland. Now I want to show you the content of this standard. We start like in other standards with forward, introduction, purpose and scope, standards for consultation, terms and definitions. I put it in red, these chapters, what I mean, which are more or most important of that. We have general, we have 3.2 personnel, organization, communication, 3.3 work areas, 3.4 work, 3.5 protective devices, 3.6 nominal voltages, 3.7 distances, 3.8 miscellaneous, and 3.9 symbols. And it continues with basic principles. 4.1 is safe operation, 4.2 personnel, organization, and subclauses from 3.3 are general, the installation manager, IM, the operation controller, the work controller, and the worker. These are 4 different functions which we need to define for electrical works. And what is a skilled person in electricity? This will also explain in this standard. And we have also instructed person in electricity. And some remarks to the complexity of work activities and objections for safety. And now I want to give more detailed information about what is safe operation. For carrying out any operation on electrical installation, an assessment of the electrical risk shall be made. This assessment shall specify how the operation shall be carried out and which safety measures and precautions are to be implemented to ensure safety. If it is determined that the work cannot be carried out as planned, the work must be stopped immediately or not be started. And if defects or any failure are observed on or in electrical installation, which may result in an electrical hazard, the installation manager for this electrical installation shall immediately informed and the necessary measures shall be taken. General, each electrical installation shall be placed under the responsibility of a person. This is the installation manager, IM. And each part of an electric installation, which is subject of a work activity, shall be placed under the responsibility of an operation controller, OC. And each work activity shall be under the responsibility of a work controller, WC. And the duties of the installation manager, IM, the operation controller, OC, and work controller, WC, may be carried out by in a single person, but it is not for complex situations, only in simple cases. And what is an installation manager, EM? The installation manager is a designated person. This is important. This is a designated, it's not a person which is not named, with the overall responsibility to ensure the safe operation of the electric installation by setting rules and analyzation of framework. And the installation manager can be a natural person from their own organization or a third-party organization. In the case that the person is from another organization, it is recommended to document the nomination, the part of the installation the person is responsible for, and the timescale of a nomination in writing. And the installation manager can delegate a part of their duties to other persons. This should be documented. Where two or more electrical installation organizations come together, it is essential that there are formal arrangements for consultation and cooperation between the installation manager of each of those installation organizations to ensure safety. And access to all places where ordinary persons are exposed to electrical hazards shall be regulated. The method of regulation and control of access shall be the responsibility of this installation manager. And the operation controller shall control their part of the electrical installation and give authorization to the work controller. The operation controller can for assistance delegate some of their duties to other person as required. The operation controller shall be a skilled person. And the work controller has the responsibility for the work activity. Where the work activity is subdivided, it can be necessary to nominate a person for each subdivision to be responsible for the safety, all under the responsibility of the work controller as the coordinating person. And the work controller and the operation controller shall agree both the arrangement of the electrical system to allow the work to take place and a description of the work activity on, with or near the electrical installation before any changes to the arrangements of the electrical installation are made or work takes place. The work controller shall be an instructing person or skilled person. And finally, a worker. Someone has to work, Each worker has the responsibility to obey the instructions received with the permission to start work and to confirm the understanding of the received instructions and corresponding safety measure of the planned working procedure. If the situation arises where the instruction or safety measures become unclear, or a worker has any doubts on the safe continuation of the work, they have the obligation to stop the work to get clarification from the work controller. If necessary, the work controller shall inform the operation controller. And the working team consists of workers who can be skilled persons, instructing person, and also possible ordinary persons. It depends from the work. And what is a skilled person in electricity? Where a task or role requires a specific competence to prevent electrical danger or injury, a suitable skilled person can be authorized to carry out a specific task or nominated to carry out a specific role, including operation controller or work controller, required by operational procedures or working procedures. And what is a construction person in electricity? An instruction person may be an ordinary person or a skilled person in training who has specific competence but has not received authorization to carry out a specific task or nominated role. The instructed person may only carry out the task or role under the supervision of a skilled person. And what is an ordinary person in electricity? An ordinary person does not possess his competence in electricity and so may only carry out tasks which do not require this competence. Or if this competence is required, the ordinary person may only carry out the task under the supervision of a skilled person. Let's go further to the content 4.4, communication, transmission of information. Chapter 4.5, work location. Then we have 4.6, tools, equipment and devices, drawings and records, signs, emergency arrangements, types of supervision. Now I will give you an overview that we need different tools and equipment and devices. We have examples of tools like insulating boots, gloves, and overshoes, eye or face protection. Sometimes we need head protection, suitable protective clothing. This also depends from the work. Arc flash PPE, insulating mats, platforms, and stands in case of live working, insulating flexible or rigid screening materials also for live working, insulating tools, conductive clothing. This is only for very high voltage working on overhead lines, operating sticks and rods. This is for middle voltage, locks, notices, signs, voltage detectors and voltage detecting systems, very important for the 5 golden rules, cable locating and cable selection devices, earthing and short circuiting equipment, and various flex marking supports. And very important, what I not described here, this is recommended only use normalized and tested devices and equipments in these cases. So the content go far with 4.11, determination of distances. We have general limit distances, determination of working distances, assessment of competence and authorization of persons, planning of work, electrical safety rules. We have the 5 golden rules, 5 is operating procedures. We have the different procedures, general operating activities, measurement, testing, and also 5.5 inspection. Then there is described the working procedures. We have general requirements, specific requirements in case of introduction, specific requirements according to weather conditions, and we have the 4 different working procedure: dead working, live working, working within the vicinity zone, and working outside the vicinity zone. And we have also in chapter 7 the maintenance procedures. They are also described. General, which personnel we need for this procedure, repair work, replacement work, temporary interruption of maintenance work, completion of management. Don't forget that by these works we have so often electrical accidents. And we have new additional information annexes for the practical presentation of organizational tasks and various work procedures. We have, like in the European standard Annex A, there are described the air distance guide for work procedures. And we have Annex B with additional information for safe working. And new is what we don't have in the European standard till now. There is Annex C, electrical hazards, which are described there, and how to manage these electrical hazards. Annex D, how we make a risk assessment. There are only examples. It's under the responsibility of this company. And Annex E, safe working procedures and documents. And what remains to be done in the future work of IEC TC 128, when we have this TC, we have a plan, what have we to do. The P members of the PC 128 recognize the need to continue work on this subject, as it appeared necessary to work on other aspects of the regional scope. We could not open this scope because it was defined. And these aspects are the safe operation of batteries and battery system. More and more we have in the network bigger and bigger battery systems, and we need also a chapter for these cases. And there is a need of integration of arc flash risks. And the request is develop a set of standards to set out the requirements for safe operation of and work activity on, with or near electrical installations. Finally, the requirements should apply to all operational, working and maintenance procedures, all non-electrical work activities, such as building work near overhead lines or underground cables, as well as electrical work activities, when there is a risk of electrical danger. And my final call is that more national committees want to participate in the next stage of the normalization, and that they will also members of the new TC 128. Everybody is invited, and it is better to have more opinion and more ideas and a more a global standard in the future. Before I want to end with my presentation, I will show you a short video that explains in very good form what is the problem if you don't recognize the distances to electrical overhead lines. Yeah, I think it's very impressive how what can happen if you came too near to an overhead line. And you will find in YouTube more adventures of numbers. This is his person. For example, all these examples are electrical problems. For example, cutting a connection cable, kink protection on plug. So often we will see it in the practice. Car battery, first aid by electric accidents. There is, you know, that you should not touch a person which is still connected with a live part. And drilling into cables, cable drum problems, the heating, and lockout, take out. It's a very good explanation about that. And often we found cables through a door, and it could be trapped in that case. Yeah? All these videos you will find on YouTube for free use. Thank you very much for your attention.
So thank you very much, Dr. Jens. We have a few questions as well to answer. So I hope you are ready for the answers. Yeah.
I hope too.
The first question is about what are the difference between NFPA 70E and the new IEC TS 63527?
What was the first number? Sorry.
NFPA 70E. There is an NFPA. NFPA 70 is the NEC of America, National Electrical Code, and it has got, B, C, D, E. The NFPA 70.
Yeah.
Yeah.
I cannot so well this American standard, but if I remember well, this is only for equipment. It's not for installation and for overhead line works. Yeah, in the scope.
Yeah.
But the scope of this technical standard, technical specification is more brighter.
Yeah. The scope of the IEC standard is more broader in comparison to NFPA 70E.
Yeah.
So that is the answer. Now we have a few people are asking whether they can an information to all participants. You can buy the IEC TS 63527 from the IEC web store. If you Google IEC web store, you will get the IEC web store, and you can you can buy the standard from that particular website. I also just put the link of the website for your information. You can also make use of it. Thank you very much for the question. Now we have a question from Mr. Rahul. Thank you for the session. Is it thermal radiography recommended as per the standards similar to NEC 70B? Okay, I understood the question. The question is NFPA 70B, which is the American standard. Again, you see, one of the difficult subject in India is the American standards are quite popular in India. In 1985, India Bureau of Indian Standards published the National Electrical Code of India, NEC. So we started calling it as NEC. But what happened is the American NEC was much more popular. So once when the time of internet came, if you Google NEC, you always get the American NEC, and sometime you get it free, and as a result, people started using it. So parallelly, for example, the arc flash analysis, there are some softwares available, and these softwares are very well marketed. As a result, NFPA 70E also became popular. Now the question is, Mr. Rahul is asking, is thermal radiography, probably he's asking about thermography, thermal imaging, is it recognized or similar to NEC 70B? The first question is, does thermography is recognized in any IEC standards? Thermal imaging. Yeah.
I'm not involved in this standardization work so deep. I was member of the TC78, and there we normalized the test procedures for arc-resistant clothing, and these are available. These standards. You have to know that this standard, what we made, this is operation. It is not. It is to ensure safe operation. It's not the question after an accident or after a problem. Yeah, the how or what we have to do if a person come nearer to electrical installation. What can happen. Yeah. So these things are described, and in the future, okay, we will put more information about that. Yeah, but only in annex. This will not part of the original standard. Yeah.
Okay, thank you. Mr. Rahul, if I have read your question wrong, probably you can raise the hand so that you can ask the question directly. Don't hesitate to ask. We have an interesting question from Mr. Ravi. Mr. Ravi Govande is our member from NFE member, very active NFE member in Mumbai. The question is, any training requirements mandatory for skilled persons or instructed persons in the standard? Does skilled and instructed persons, do they need any training?
Yeah, we refer to other standards. In IEC, we have more standards which define what is an electrician or what is a normal worker, and we wouldn't make a new definition for that. Yeah, and in some cases we have more different stages for electrical personnel. Yeah, it depends on the national requirements. So we have only this description, and for example, if we want to compare, like in Germany, an electrician needs 3 years of occupation of education, yeah, training and practical training. So it needs 3 years. Yeah.
Yeah. I think this is actually a big challenge in India at the moment. We have the electrical safety is not a part of our curriculum. As a result, most of the safety measures which we talk, the skills and the competency, it varies from place to place in India. South India, we understand it in one way. Maybe in North India, it is in a different way. Eastern part of India in a different way, and it's a risky job. And that is what we are trying to address in NFE. We are trying to educate everybody about the IS standards. So
I can refer to the website of our electricity section, where we have a publication for the selection of electrical instructed person. Yeah, we have a publication for this manner for different works, which formation, which knowledge they need. Yeah.
Okay. Actually, in NFE, we lasted 2 years. Our association is only 2 years old. So we almost 1 year we worked and we made a scheme for as per ISO 17024 for qualifying the electrical designers and electrical contractors. So now the scheme is running, but very slow. So here we actually defined what kind of qualifications are required, what kind of trainings are required, how the person is qualified, and so on. So thanks for all the answers. Now we have an interesting question from Mr. Sridhar Reddy. What is the IEC standard for skin effect heat tracing? Skin effect heat tracing. Probably, I think it's not our subject.
Heat tracing? What is tracing? Heat stressing or
tracing.
in case of
Skin effect heat tracing. Mr. Reddy, sorry to inform you that the question is not very clear for us. So probably, if you are there, you can raise the hand and probably you can have a talk. Mr. Balasubramaniam is asking, I am making which IEC standard need to electrical wiring assessment work? Oh, the question is not very clear. Mr. Balasubramaniam, if you are talking about the electrical wiring, then it is IS 732. IS 732 is the standard for electrical wiring in India. The next question, can we merge the negative volt from DC and neutral from AC? Oh, this is also not participants. Please understand that we are specific to a subject. We would request to put the questions related to the topic. Otherwise, it makes a little bit difficult. Here the question is, can we make the negative volt from DC and the neutral from AC and ground it for measuring the voltage from same? Oh, sorry, this is quite complicated. The question itself is very difficult to read. Okay, Mr. Rahul has replied that, okay, my question is clear. Thank you for the explanation. On Mr. Ningaraja is asking, is Puran analysis test is must for all transformer oils? If yes, what is the frequency recommended? My God, this is also, I'm listening for the first time this question. Puran analysis test. Did you heard of this kind of a test for a transformer oil?
Transformer?
Yeah, for a transformer oil. Okay, probably this is out of our today's topic. Yeah. Okay, Mr. Arvind Deshpande is asking, which is the best method for doing or calculating arc flash analysis energy? Arc flash energy. What is the best method for calculation? Yeah.
You can look to our website of electricity section. There is also a leaflet with information about calculation and risk assessment for arc problems. And there's also available programs or apps to calculate that. It is AFP, what is the AFPV is an American standard, and we have also an European standard, but for both, they have calculation. Yeah.
NFPA 70E. NFPA 70E.
Yeah. Sorry, it is ATPV test. It is American standard. Yeah, it's an open high voltage arc test, and we have a European low voltage test with a box. But both are making heat to the material, and with this information you can make a calculation what could happen in your installation and which protection clothing you need for the special cases. Yeah. But nevertheless, at first it is better to be of distance or you're dead working. Yeah.
True. Don't put the hand into the live parts of an electrical installation, or don't go closer to it. Mr. Aravind, if you look at the standard TS 63527 in the clause C 3.3 in the annexer C 3.3 is explaining about arc flash risk assessment. So if you have the standard, probably you can also find the information arc flash risk assessment in this IEC standard. Yeah.
make a reference to this TC78 publications about these test procedures. Yeah, it is connected between.
Yes. Incidentally, I was just going through during the presentation. I was going through one of the session. The arc is considered so low that it does probably not cause a permanent injury. In the following cases, the incident energy can be considered so low that arc flash protective equipment is not required. The condition number one, the voltage is less than 400 volt AC and the short circuit current is less than or equal to 1 kiloampere. The voltage is less than 400 volt AC DC and the upstream fuse rating is less than or equal to 63 ampere and the voltage is less than 50 volt AC or DC. Okay, this I just read a few lines from the standard. So, gentlemen, participants, please look into the standard annexure C. Thanks for the question. So also Mr. Ravi, yeah, please. Yes, please.
Then another remark: we have no limits for the voltages, yeah, because it is valid for only 10 volts. For a big battery, you can have a very strong arc with a high current, and it is also for high voltages but a low current. Yeah, it is valid for all cases. Yeah.
Yeah. Thank you for that explanation. Mr. Ravi is asking, how can you get the document? Mr. Ravi, we will search in the ISSA website. We will take out this information and share it in our group so that this information can be with everybody. Mr. Sanjeev
on my last page, there was the website, no?
Yeah, Mr. Sanjeev Kumar. In India, CEA has technical standards for construction of electrical plants and electric lines and is notified regulation which followed the transmission generation of electrical installation. Will this standard applicable as already CEA standard is available? Okay, Mr. This is typically for India. Let me answer. Mr. Sanjeev Kumar, CEA is having the regulations to maintain electrical transmission lines and distribution lines. But some of the critical aspects, if you look, we have to follow the IS standards as well as the IEC standards. Basically, the IS standard is our national standard in India, and in the absence of an IS standard for any subject, IEC standards are applicable. So indirectly, this standard is definitely applicable for India, even though it's an IEC standard. This is because of some of the clauses in the regulation. So we are lucky that even without an IS standard, we can use it. And for your information, very soon we will have the Indian equivalent, or probably we already decided to have, nationalize this or adopt this particular standard for India, because it's very important for us. You would like to add something, Dr. Jens?
Yeah, another remark. The European standard is 5110, the EN 5110. It has a part 1 where you will find the national legal requirements, because operation is not only a standardization matter. Some governments, some legal institutions are making specific national rules. So it is at first stage you have to fulfill these legal requirements, and if there are not legal requirements, you use the standardization, the standard rules. Yeah. And you can make it in a similar way for the different states in India, because they have other regulations, other national requirements, perhaps.
Yeah. Okay, thank you. So Mr. Vijay Kumar is asking which IEC is used for arc flash studies and assessment. Mr. Vijay Kumar, this particular standard, the clause C.3.3 is giving the arc flash risk assessment, as well as the conditions are very well explained. So the easiest way is to refer to the standard which we are talking, IEC TS 63527. So thanks for the question. Mr. Sudipta He's asking, I am from inspection body. Being an inspection engineer, registration with NFE will be helpful. Oh, Mr. Sudipta, we are working for creating awareness and develop skills for engineers to make our nation safe. So if you are interested in electrical safety, then definitely you can become a member. The next question, is there any specific risk methodology that need to be applied for the IEC TS 63527? Is there any risk assessment explained in this particular standard is the question.
Yeah, as an annex, we have the example how to manage the risk assessment. Yeah.
Yes. This is the annexer D is talking about the risk assessment. So carrying out a risk assessment is specified in this document as a fundamental requirement for operation of the electrical installation, planning work, selecting working methods and taking the various decisions necessary to keep the workers safe from the dangers of electricity. Yes, of course.
Yeah.
Please refer annexer D. So we have another question. Please clarify whether arc flash study is recommended or done for switchyard equipment. So the question is whether arc flash study is recommended for outdoor electrical, high voltage electrical installation. You have any answer for that, Dr. Jens?
Of course, we refer to this TC78, and TC78 he has these test standards, and with this classification, you receive information till which what's the name, heat energy personal equipment is withstanding this heat flux. But you have to know or calculate which intensity has the heat flux of your installation. It depends from so many things, yeah. And in sometimes or in many cases, electric companies are looking to the special points of their network where their workers are working often. And then we calculate at this situation, at this the situation of this workplace, which maximum of heat flux can occur. And then they decide you cannot work there if it is too high, or you need minimum this protective equipment, this trousers and so on, and or other case that you don't need nothing because the heat plug is very, very low. Yeah?
Yes. Thank you. Now we have the last question. We know IEC 63527 focus on electrical installation operational safety, but will the new standard impact the CE marking, which is basically product safety? Will this standard influence the conformity assessment CE marking of any of the products is the question.
I don't think so, because we have the basic rules for an equipment for installation, and the other question is what can happen if operator have to go to this or maintenance on this installation. So I don't think so that it have an influence to the what's the name of the standards of the equipment.
Yeah. Thank you, Mr. Dr. Jens. We have Mr. Davis. He is our member from NFE. Mr. Davis has raised the hand. Mr. Davis, you can speak and you can ask the question directly.
Okay. Thank you, Mr. Kumar. My question to Jens. Before that, I wanted to also mention I had been to DGTM ISA Dresden in 2017, representing Siemens India, and attended the train program for electrical safety. Now, what I could see from the training center over there, a lot of emphasis have been given on the demonstration of the theory, what we are learning. And in particularly India, we do many time a lot of learning through theory, but there I could find, and we have, that time I was working for Siemens Limited. Now I am retired. Now I come back to Siemens India during that time, and then we also set up a training center. Now here one question which I would like to ask Dr. Jens. You have been talking about golden rules of electrical safety, 5 golden rules. I think that is one of the most important rule which is followed, what I could see in Europe for the electrical maintenance. And if you can throw some lights on that, it would be great. The importance of golden rules of electrical safety with respect to electrical maintenance.
It's the most important base for electrical work. Yeah. And we have also publications of our IEC, but where was this Siemens Education Center in Delhi or?
No, I have attended the training in Dresden, Germany.
In Dresden. Yeah. Okay.
Yeah. ISA, that was a part of Siemens India and Siemens AG, and then coordinating with the BGTM. So if you can throw some light on the 5 golden rules, the importance of it, so that would be great. I think that is one of the most important area for the maintenance.
Yeah, we have this chapter also in this technical specification, and there is explained how they implement these rules and what you have to do. But you have different cases. If you are working on an equipment, or you're working on the overhead line, or you're working a cable, these are different situations. At the beginning of my presentation, they showed this yellow book, and this yellow book gives the practitioner more information about the standard and how they can realize the special risks and not realize find the relevant protective measures. And 5 golden rules, okay, we'll have these titles, but behind that we have different things to do in the special cases. Yeah.
Okay, can we have some documents shared, if possible, on this particular topic?
We have more general information on our website for these golden rules, but we have also a leaflet for that. You can look, but it's too complex. Yeah.
Understood.
But in the standard, you will find detailed information. Yeah.
Okay. Thank you. Thanks a lot.
Thank you, Mr. Davis.
Yeah.
Thank you. So we had a very nice, discussion as well as question answers, and of course the presentation. Thank you very much, Dr. Jens, for this detailed explanation from the standard. Also, we had a good participation. At some time, I was looking at the screen. It was about 260 people participated. Also, we will be uploading the video very soon in our website, in our YouTube, and then few hundreds also will look into the YouTube video. Actually, the subject is of very big importance to us, as we have one of the largest networks of electrical, generation, transmission, distribution, and solar PV and usage in our country. And quite unsafe conditions exist in several parts of the country. And the electrical safety is becoming a very, very important subject, and we are also putting all our efforts to educate people to implement more knowledge and more standards into their minds. So over to you, Dominic, sir.
Nothing much, sir. Thank you so much to joining from Germany. Mr. Gopakumar joined from Chennai. I stay from Bangalore. And thank you all the participants. I look forward to you to join NFE. And very soon we'll be announcing the next webinar coming soon. And we look forward to see you in any other subject that you would like to share to Indian audience, Indian electrical engineer. We are most welcome, sir. You can also recommend some of your friends to join the NFE's webinar programs. Thank you, sir. Wish you all the very best. Thank you, Gopakumar, sir, for taking up moderating the whole session. You have a wonderful week. Look forward to see you, sir. Thank you. Bye-bye.